Transcranial Photobiomodulation or neural development disorders, autism, ADHD, and Down syndrome. This is a summary of the paper that was published in July of 2024 with the authors that include Paulo Casano. Let's explore this therapeutic potential of transcranial photobiomodulation as a therapeutic intervention for neurodevelopmental disorders. TBM involves the delivery of light photons through the skull to modulate brain function. Points to review that are highlighted in this resources are the mechanism of the actions of transcranial photobiomodulation, the therapeutic potential of transcranial photobiomodulation, the clinical evidence for using transcranial photobiomodulation, the safety, then the parameters of the transcranial photobiomodulation, the future directions and future research. 9 studies were identified throughout all the research, including 1 preclinical and 8 clinical studies. 5 were on autism, 2 were on ADHD, and 1 was on Down syndrome. The mechanism of action is that transcranial photobiomodulation uses red and near-infrared light to stimulate mitochondria, creating more energy for brain function. It improves mitochondrial function and enhances the ATP production, improves cellular health. The proposed mechanisms also include modulated oxidative stress and reduced neuroinflammation. And this is a graphic of it, that the transcranial photobiomodulation for these 9 studies that they reviewed changed mitochondrial function, modified reactive oxygen species, decreased microglial activation, decreased astrocyte activation, and decreased concentrations of pro-inflammatory cytokines. This is the mechanism of action. The therapeutic potential of transcranial photobiomodulation has shown promise in treating various neurological and psychological conditions, including traumatic brain injury, stroke, Alzheimer's disease, Parkinson's. And this review suggests that transcranial photobiomodulation could be beneficial for neurodevelopmental disorders by improving brain bioenergetics and reducing inflammation and oxidative stress. In neurodevelopmental diseases, we have mitochondrial dysfunction, increased production of reaction oxygen species, increased microglial activation, increased astrocyte activation, increased concentration of pro-inflammatory cytokines. What we find is if we apply red and near-infrared light to the brain with our helmet or something along that line, that mitochondrial function improves, modulation of the reaction ROS, decreased glial activation, decreased astrocyte activation, and decreased concentrations of pro-inflammatory cytokines. The mechanism should work. The clinical evidence for transcranial photobiomodulation reviews both the preclinical and clinical studies, noting that while animal studies have demonstrated significant benefits, human trials are still limited and often show different change results. But transcranial photobiomodulation showed efficacy in autism spectrum disorder for improving disruptive behavior, better social communications, less cognitive rigidity, better sleep quality, and more attention. And in the ADHD studies, they found enhanced focus and enhanced attention. Then in the Down syndrome, which was only 1 fever, they showed improved motor skills and verbal fluency. And we're going to review that right now. The authors emphasized the need for more well-designed RCTs to establish the efficacy and safety of transcranial photobiomodulation for these neurodevelopmental disorders. The safety parameters of transcranial photobiomodulation is generally considered safe, with no significant adverse effects reported in the reviewed studies. And that's really a significant. It can't hurt you. The future direction of further research call for more research to refine the transcranial photobiomodulation protocols and explore its potential in a broader range of neurodevelopmental disorders. It's looking at like different neurodevelopmental disorders. It also suggests investigating the combination of transcranial photobiomodulation with other therapeutic modalities to enhance treatment outcomes. In conclusion, the paper provides a comprehensive review of the current state of transcranial photobiomodulation research and its potential as a non-invasive, safe, effective treatment for neurodevelopmental disorders. And then, here are the references with the DOI there to just look up. And further, future research has already been started. One was a grant to Richard Fry on the safety and efficacy of a transcranial photobiomodulation for epileptiform activity in autism. And uh, this is the inclusion in criteria. They're looking at kids 4 to 12, and there are 10 weeks that will occur only twice a week. Will they give them care, right, for 10 weeks, and then they'll check out what's up. Then this is his grant that he got in 2023. Also, this professor at Harvard is doing evaluation of transcranial photobiomodulation in autism, a double-blind, placebo-controlled, randomized study. This is the study that they were asking for, and it's currently underway. And this is, I guess, it's another study at the University of Texas looking at autism research projects with non-invasive near-infrared light stimulation. And that's with Gonzalez Lima, ISD work. They're working on this to give us more information. And this is started in August. They initiated this autism research project. So we're looking forward to hearing from these people. It's going to be a great study because those are great scientists. And this is another area that they're talking about. From May, treatment targets specific brain areas without any adverse reactions. It's pretty cool that they're looking at this minimum clinical difference and looking at these children age 2 to 6 using just the near infrared light on the brain. New research this is going to be the full use of transcranial photobiomodulation for neurodevelopmental problems, including Down syndrome. And this is new impressive research. Right? This is a transcranial photobiomodulation Down syndrome. This is an Edgar, 40-year-old individual with Down syndrome. And this is a research paper that was published showing very astonishing results of these children with Down syndrome following transcranial photobiomodulation. Not only was it safe, with no adverse events being reported, but the cognitive function of these individuals had improved overall and steadily. School performance had improved, socialization, speed, flow, motor function, even their growth got taller. They were slightly higher than their peers with Down syndrome. Their immunity benefited. They had less infections and even less facial twitches. This is the drugs made by an 8-year-old girl with Down syndrome undergoing photobiomodulation therapy. Baseline at 14 days, at 28 days, and at the end of their second cycle. Now, these children had 2 photobiomodulation therapies a week in the office. And then they had a bunch, and then they had a space, and had this very minimal amount of light being delivered. But a huge change in really an ability to communicate. And this is what they showed with the fine motor skills. And this was the paper, draw my portrait, the doctor asked. And then this is what the girl did. This was published in 2000. And this is from 8 weeks later with only like 14 treatments. And they also asked a 13-year-old girl to draw at 6 weeks and in 16 weeks, draw a circle. And you could see that the motor skills improved greatly, the ability to concentrate. And a team of 4 researchers published this case study concerning the use of transcranial photobiomodulation on 3 children with Down syndrome. 1 8-year-old girl and 2 boys aged 11 and 12. They've got 2 sessions per week for 4 weeks. That's very low power. Then the parents was very positive, improved motor skill, better verbal fluency, better investment activities at home. Children needed less supervision. The parents described their child as calmer, less hyper, more to relax, participate in activity of the moment. And they could make better drawings. This is a study that they are proposing a protocol to study more about this using photobiomodulation to help muscle activity, head posture, and salivary levels. They're going to check these children with sleep bruxism, then grind their teeth at night. Again, this is a randomized controlled clinical trial then they're going to do a new one, another one this looks like in Brazil. And there is cognitive decline and dementia in Down syndrome. So Alzheimer's disease is most likely universal in older individuals with Down syndrome due to having 3 copies of the amyloid precursor protein, AP gene, resulting in amyloid beta plaque deposition, the same plaque that they propose hurts people's brains with Alzheimer's. Older adults with Down syndrome are high risk of experiencing cognitive decline, with more than 80% likely to develop dementia by age 65. That means their timeline. So if they can live to 65, they're going to have dementia. But the timeline of behavioral and mild cognitive impairment can be decades beforehand. Their behavior and their cognitive status can really go down very early on. And that's what we found with Edgar. Efforts have been made to understand the relationship cognitive decline and comorbidities such as epilepsy and hemorrhagic stroke in these individuals. So it's very common. And Edgar was experiencing cognitive decline. He became less talkative. He was having difficulty going to the bathroom and making it there, cleaning himself, didn't want to go out, was just becoming a person with mild cognitive impairment, maybe even all the way to dementia. So Down syndrome and the glymphatic system, this is a potential connection. So Down syndrome is a genetic condition characterized by the presence of an extra chromosome 21. One of the key challenges associated with Down syndrome is the development of neurocognitive impairment. Recent research suggests that the glymphatic system might play a role in these impairments. So what is the glymphatic system? The glymphatic system is a network of channels that's called clear waste products from the brain. It's essentially the brain's waste removal system. And these channels are primarily located around blood vessels and rely on circulation of the cerebrospinal fluid. And this is the kind of a graphic representation that this is the ventricles inside the brain, and it's produced in here. The fluid is produced in here. So you make about 150 milliliters of this fluid a day. And as it flows around the brain and through the brain, like here, it flushes out these chemicals. And then flushes it out of the system. So the potential connection Down syndrome and the glymphatic system is there are several lines of evidence that suggest a potential connection between Down syndrome and lymphatic system dysfunction. You can have that beta amyloid accumulation. One of the hallmarks of Alzheimer's disease, what often occurs in Down syndrome, is the accumulation of amyloid beta protein in the brain. The glymphatic system is crucial for clearing these beta proteins out. The studies have shown that glymphatic dysfunction can lead to increased amyloid beta accumulation. 2 is neuroinflammation. Down syndrome is also often associated with neuroinflammation, a process that can damage brain cells. And glymphatic dysfunction can contribute to neuroinflammation by hindering the removal of these inflammatory molecules. Sleep disturbances. Sleep is essential for glymphatic function, and individuals with Down syndrome often experience sleep disturbances. And these disturbances can impair the glymphatic system's ability to clear waste products. While the exact relationship between Down syndrome and glymphatic dysfunction is still being explored, the evidence suggests that impaired lymphatic function may contribute to the neurocognitive challenges faced by individuals with Down syndrome. Research in this area could potentially lead to new therapeutic strategies for individuals with Down syndrome. Cerebrospinal fluid challenges in Down syndrome. Cerebrospinal fluid is that fluid that's produced inside those ventricles and flow around the body. It plays a vital role in the brain's health, providing cushioning, nutrients delivery, autoimmunity, and waste removal. Individuals with Down syndrome often face challenge related to cerebrospinal fluid and its flow, because they can have these are marked problems like hydrocephalus. Is a condition where excess CSF accumulates in the brain's ventricle, leading to increased intracranial pressure. Then hydrocephalus is more common in individuals with Down syndrome, especially those with an unusually, different framing thing at the bottom of the skull. Talk. The glymphatic system dysfunction, we showed about that. These network of channels that help clear waste products from the brain. And studies suggest that individuals with Down syndrome may have impaired lymphatic function because they have excess over increased accumulation of waste products like amyloid plaques. And as a consequence, this can contribute to the neuroinflammation and cognitive decline. The system becomes overwhelmed because the brain is making, of Down syndrome, is making too much amyloid beta. The sleep disturbances is another reason, because sleep is crucial for lymphatic movement and pushing these fluids around. And individuals with Down syndrome often experience sleep disturbances, which don't allow this CSF related flushing. Then the neuroinflammation. So CSF is involved in the immune response of the brain. Increased inflammation or lack of the ability to flush these waste products out. With people with Down syndrome often have higher levels of inflammation, which can impact CSF fluid and its function. We also have cranial cervical instability, then cervical malformations. So the top of the neck and the middle part of the neck can be malformed of bones. Then cranial cervical instability, cervical malformation are two significant concerns in individuals with Down syndrome. This condition involves the bones and joints in the neck, and they can have serious implications for neurologic health. So cranial cervical instability is a condition where the first two vertebrae of the neck are abnormally loose or unstable. And individuals with Down syndrome have higher risks. They do have this due to the differences in shape and structure of this vertebrae. They can get neck pain, difficulty swallowing, and all sorts of neurological symptoms just from that. And you need to have an X-ray or an MRI to see that. And then the cervical vertebrae in the neck can be abnormally shaped. And these types of malformations occur in Down syndrome and stenosis and everything like that. And that's part of the lymphatic flow, the CSF flow. Here's an example. It's not precisely, but this is the cervical malformation, and these are not aligned properly. The brain itself sit down to each lung, the drainage or the flow of these fluids around. If the cervical vertebrae are misaligned or normally shaped, they can create physical obstruction to the CSF flow. This can lead to increased pressure in the brain and the ventricles, and that's one of the reasons that they get the hydrocephalus, puffing up. Instability of the upper part of the neck can also disrupt the flow because this movement and misalignment of the bones can also interfere with the flow, and the brain can invaginate or push down. Brain. So this is the normal ventricles that we saw, and this is the brain tissue that's around there. When you have hydrocephalus, the pressure builds and the body doesn't stop making the fluid. It's got nowhere to go. And so the ventricles get bigger, the head can get bigger. And that's really not good because it means that the lymphatic system, this flow of removal and immune and regeneration is blocked. So these hydrocephalus caused by like several factors. Hydrocephalus is a condition where excess cerebrospinal fluid accumulates in the brain ventricles. It's more common in individuals with Down syndrome. Then, because you can have cranial cervical instability or malformation, the base of the skull, foramen magnum, big thing, big hole down, is often larger in individuals and lead to increased pressure, but it also can the brain can fall in there and squeeze everything. Then the aqueductus sylvius, which is a smaller channel between the ventricles, can be narrow. And it connects the third or fourth ventricles. And if that's small, then it's got no place to go, and it balloons up in there. Also, it restricts the flow of CSF. And then that leads to lymphatic system dysfunction because it's a network of channels that clear the waste, and individuals with Down syndrome may not function as effectively. And you have buildup of CSF and waste products. And neuroinflammation is the same thing. Process can damage tissues and interfere with CSF flow. I was an author on a paper that described how photobiomodulation influences the lymphatic system and we propose that it can help augment the brain's lymphatic drainage system. And there's been a bunch of research on this that shows that it can increase or accelerate this CSF flow. And this is a little video about this thing here. So that's where we went with this, that using the light not only shows to help the mitochondria, reduce the neuroinflammation, but it will help flow of uh, the CSF in the glymphatic function in these children to reduce inflammation, increase their cognition. And that's how it works. So after only 2 weeks of using the light, Edgar actually wanted to go outside, was talking to all of his family, has had less, no actions going to the bats. And all this is because of the things that we propose, that the light helps the brain work better.